Okay, now this problem is really important for students to get through because we're going to end up having to multiply or divide by a negative. Basically what we've got is A is not by itself, A is being multiplied times 10, a negative 10. So to get rid of that multiplication between the negative 10 and the A, we have to divide by negative 10. And when we divide or multiply by a negative, we have to switch the sign. So in this next step, we're actually going to end up with the arrow pointing the other way, the inequality switching directions. And so negative 10 divided by negative 10, that portion is just a 1, because anything over itself is just 1. And 1 times A is just A. Over here we got 10, or 100 divided by 10, which is 10, and a negative and a positive make a negative. So that's really what we're looking at. And so to solve that graphically, which actually this example doesn't require you to graph it, but just I thought I would go ahead and show that. Negative 9, negative 11. A is less than, but not equal to, negative 10. So that would be how we would show that if it asked us to graph it. But the important part is to notice that as soon as you multiply or divide by a negative, you've got to switch the sign. So that's the procedure. As far as understanding the concept, though, I'm going to draw a line here because now what I'm about to talk about is separate from this problem. I just wanted to show my students how to rationalize, how you rationalize the idea that switching the negative sign, like multiplying this side by a negative 1, for example, would switch this negative sign to a positive, and it would also switch this positive to a negative. So switching the signs is what multiplying or dividing by a negative really does. I wanted to come up with an example so my students could see why that has to take place. And so what I have my students do is, pretend the 11 or the x is something like an 11, or any number where this would be true. If we pretend that x is actually an 11, then this statement really is true. Negative 11 is less than 10. That's true. So if we multiply both sides by a negative 1, and I guess this will just have to look like this. I've put in the parentheses. Negative times a negative is a positive. 1 times 11 is just 11. So that takes care of this side. Negative times a positive is a negative, and then 1 times 10 is 10. So here we have multiplied by a negative, but we didn't change the less than sign. And is this still true? Is 11 less than negative 10? No. What we did was perfectly legal, but the result is false unless we turn this around. So as far as understanding of the concept of why multiplying by a negative switches the signs, I offer this example to my students. You've got to pretend that this is a number such that this would be true, like negative 11 was less than positive 10. And then when you multiply by the negative on both sides, you end up with something false if you don't change the sign. So that sort of proves, hopefully, or at least gives some kind of a tangible example of how you've got to change the direction of the inequality to maintain the truth of the statement. Because this would not be true if it didn't say greater than, as we showed just a second ago. So that's number 47 and my example of how to rationalize why we do that.